In this section, we're going to look at a variety of quadrilaterals and look in particular with their characteristics. We're going to start with a parallelogram. In a parallelogram, opposite sides are parallel and congruent. So that means side AD is parallel to side BC, and side AB is parallel to CD. That also means that side AD is congruent to side BC, and side AB is congruent to side DC. Okay, so to recap, AB is parallel to CD, and AD is parallel to BC. AB is congruent to CD, and AD is congruent to BC. Okay. Opposite angles are congruent. I'm going to write them as opposed to marking my diagram because it's going to get rather messy. So opposite angles, they're across from each other. So angle A is congruent to angle C, and angle B is congruent to angle D. The other characteristic is that they're consecutive angles. That means angles that are right after each other or next to each other are supplementary. So we have two of them here. AB, angle A and angle B are supplementary. Angle C and angle D are supplementary. But as we go around the parallelogram, angles A and B are supplementary. Angles B and C are supplementary. C and D are supplementary, and angles A and D are supplementary. So those are the characteristics of a parallelogram. We're moving on to a rectangle, and the rectangle is very similar to the parallelogram. We have opposite sides that are parallel and congruent. We have opposite angles that are congruent, but we have a new stipulation. They are all right angles. So I'm going to go ahead and mark the angles in here as being right angles. And I'm going to mark the sides as being parallel and congruent. And just like in a parallelogram, we have consecutive angles are supplementary. So again, parallelogram and rectangle, the only difference is that a rectangle has 4 right angles and a parallelogram only has opposite angles that are congruent. Let's walk through some examples. This is find the missing angle. So we're looking at angle T and we're given angle S. Notice they are consecutive angles. So according to our chart, consecutive angles of a parallelogram are supplementary. Supplementary means they add up to 180. So here's our setup. So our missing angle is going to equal 74 degrees. Okay. If we look at example 2, we have two sides of the parallelogram. Opposite sides of parallelograms are congruent. So these two sides are opposite and they're congruent. And when they are congruent, that means their measures are equal. So our setup, 20 equals 3x minus 4. Add 4 to both sides. Divide by 3. And we get x equals 8. Okay. Now our next two examples, we need to find the measure of an angle and the length of the side. And notice we are given algebraic expressions. So for both of these, we need to find x first. And then once we know what x is, we can substitute it into the expression that we're looking for. In particular here, we're looking for angle F, and over here, we're looking for side FG. So these are opposite angles. Opposite angles are congruent, which means their measures are equal to each other. Okay. If I move my variable to the left, I have negative x equals negative 4, which means x equals 4. But again, we're not solving for x. We want to find the measure of angle F. Measure of angle F is 20 times x. So we're going to take 20 times 4, and that's going to give us 80 degrees. Example 4, we have a parallelogram. That means opposite sides are congruent, which means their measures are equal. So we set 2x minus 7 equal to 5 plus x. I'm going to move my constant to the right and my variable to the left. When I move it to the left, I'm going to subtract it, so that gives me x. When I move my constant to the right, I'm going to add that, so I get 12. Again, we're not solving for x, we're solving for FG. FG equals 2x minus 7, so that's going to be 2 times 12 minus 7, which gives us 17. Squares are very similar to parallelograms and rectangles in that opposite sides are parallel, but now all sides are congruent, opposite angles are congruent, and right angles, and we still have our supplementary. Okay? So all my angles are right angles. My opposite sides are parallel. Notice I'm going to use two different numbers of arrows, but because all my sides are congruent, I have a single tick mark on all 4 sides. Again, A plus B is 180, angle B plus angle C is 180, angle C plus angle D is 180, and angle D plus angle A is 180. Okay? So find the missing angle. We have a square. All angles are right angles, so that means the measure of angle S equals 90 degrees. If you can't remember that, S plus R is 180, R is 90, and 180 minus 90 is 90. Okay. Example 6, we have angle M is 30x. We know it's a right angle, so 30x equals 90, x equals 3. The next quadrilateral we're going to look at may be new. It is a rhombi. Okay? Opposite sides are parallel, all sides are congruent. So it sounds an awful lot like a square, except notice that in a rhombi, only the opposite angles are congruent. There's no information, they do not have right angles. Okay? So, I'm going to mark the parallel sides. And because all the sides are congruent, I'm going to use the same tick marks. And because I don't want the diagram to get too messy, angle A is congruent to angle C, and angle B is congruent to angle D. And again, consecutive angles are supplementary. Okay. So let's find the missing side on example 7. This is a rhombus. All sides are congruent. So if this side, and it's very difficult to read, it's 15.8. Since all sides are congruent, then NK equals 15.8. Okay. Example 8, we want to find angle Y. It is opposite angle W. Because they are opposite, we know that angle Y is congruent to angle W, which means the measure of angle Y equals the measure of angle W. So the measure of angle Y is going to be 68 degrees. The last quadrilateral we're going to look at is a trapezoid. We're going to look at the general trapezoid and the isosceles trapezoid. Okay? In a trapezoid, opposite sides, you have one pair of parallel sides, and these are called the bases. And so I'm going to highlight the word bases and highlight the bases here. Okay. Consecutive non-base angles. Okay, so the base angles are AC and BD. So consecutive non-base angles are supplementary. So A plus B equals 180 and C plus D equals 180. Okay. Because it's a quadrilateral, the sum of all four angles is 360. So that's your general trapezoid. Now, we create an isosceles trapezoid. We have our parallel side called the bases, but now the sides that are not the parallel sides, these are called the legs. And in an isosceles trapezoid, the legs are congruent. So in this case, if this was an isosceles trapezoid, side AB would be congruent to side CD. Okay. Again, our non-base angles are supplementary, but if it is an isosceles trapezoid, then your base angles are congruent. So these right here are your base angles. And that is only for an isosceles trapezoid. If you don't have an isosceles trapezoid, the best you can say is your consecutive non-base angles are supplementary. So let's look at some examples. Example 8, find the missing angles. So we're looking for angle K. This is not indicated to be an isosceles trapezoid. So what we know from the trapezoid, these are consecutive non-base angles. So the measure of angle J plus the measure of angle K equals 180. J is 80 degrees. So if we subtract 80 from both sides, the measure of angle K is 100 degrees. Looking at example 9, because I have these two sides that are congruent, and this is a trapezoid, this is an isosceles trapezoid. And these are base angles. In an isosceles trapezoid, our base angles are equal. So the measure of angle U equals the measure of angle X. So that means angle X is 67 degrees. Our last example, we have a trapezoid. We don't know that it's isosceles, so we can't assume that. And we want to find the measures of angle B and angle C. And we're given the measure of angle A as 100 degrees and the measure of angle D as 75 degrees. Since it is just a general trapezoid, what we know is that A and B are supplementary, C and D are supplementary. So if I want to find the measure of angle B, It's going to be 180 minus the measure of angle A. 180 minus 100, which gives me 80 degrees. To find the measure of angle C, it is supplementary to angle D. So we have 180 minus 75. Angle C is 105 degrees. Now, the last thing we're going to look at is naming quadrilaterals based on their characteristics. If I look at 11, I have two pairs of parallel opposite sides. That's all I have. So the most specific I can name this is a parallelogram. Okay. Here I have a quadrilateral with one set of parallel opposite sides that are parallel. So this is a trapezoid. I don't have any information about the legs, so I cannot say it's isosceles. 13, I have opposite sides that are congruent and all right angles. And notice that this pair is congruent, this pair is congruent, but they're two different lengths. This is a rectangle. Moving to example 4, I have 4 right angles, but notice all 4 sides are congruent. This is a square. And then our last one, all I have is 4 congruent sides. That is a rhombus.